Hi, so today I'd like to do a really quick video just going over some of the causes of the 12-inch Retina to not have a backlight. This is also applicable to the Retinas from 2013 through 15, but it's something that I think a lot of people are going to get confused about, and a lot of people are going to kind of screw themselves on if they don't know exactly how this failure mode occurs. So I'm just going to try to explain this and then get out of here. It looks like we're already dropping over 1,000 frames because I use Time Warner for internet. And why would I stream at 9 megabit on a 20 megabit per second connection that costs $4.50 a month? So I'm just going to lower my bit rate to something that's more manageable so that you can actually see my screen. And hopefully I stop dropping frames. All right, so now I'm just going to switch over to the backlight circuit here and give you an idea of what it looks like on the 12-inch Retina. So over in front of here, you should see the 12-inch Retina backlight circuit. This is a standard DC to DC boost circuit. If you don't understand how a DC to DC boost circuit works, you can watch one of my other videos on how a DC to DC boost circuit works. I try to explain it as simply as possible. Long story short, you have input voltage here at 8 volts. You have output, which is going to be about 25, 27. And the way we're going to get there is we have a coil. Right in front of this coil, there's going to be a chip that switches the voltage from here to ground. That's going to make the coil rage, like my last video on libertarianism. And after the coil rages, it's going to output a higher voltage. Now, this system is a little bit more complicated than the older A1278s and things like that. So the way this is going to work is we have two additions to the circuit. The first addition to the circuit is this current sensing circuit over here. Now the way the current sensing circuit works is that there's a resistor up here that is going to have a very small voltage drop across it, and that voltage drop is going to be dependent on how much amperage the circuit is using. By measuring the voltage at the beginning and the end of the resistor, we can tell how much amperage the backlight circuit is using. So if there's a short to ground on these, which is really cool, rather than burning the connector like what happens in every single one of these videos that I do, where the connector is completely burned and missing pins and just destroyed, it's going to say, hey, you know what? Maybe we shouldn't send voltage there because it's using too much current, which is a progress. I gotta say, honestly, hats off to Apple. You did something good with your hardware. Every now and then it's going to happen, maybe by accident, but I appreciate it and I give you credit. So you have to check for this. But the other thing that's going to go on is that it's also going to talk to the screen. So over here you see this I2C line over here, and this is something that did not occur on the older MacBooks or on the A1278s, where you had you had DDC circuit, but that was nothing like this. It was much less complicated. It was just sharing, I'm a screen, this is the resolution. Here, you have this I2C line to the screen, and this is something that's a little new. And it needs to, actually I shouldn't say that this is new, because DDC it's a different protocol, but it's pretty much doing the same shit. Oh well, an engineer is going to roast my ass for saying that, but such is life. Anyway, so you have this I2C line to the screen, but what makes it different is that in the older circuit, that did not, it was just the CPU communicate, or the PCH communicating with the screen. The PCH would communicate with the screen, not the LED driver. Yeah, no, so I'm right, okay. No, I can't get roasted by engineers here. Yeah, I am correct there. So in the older machines, the screen did not have a direct communication line with the LED driver, whereas in this one, the screen has a direct data communication line with the LED driver. So here, U7701 is the LED driver, and it's going to talk, what did I just do? Giving back my, yeah, and this is the screen connector over here. So the screen is going to directly talk to the LED driver. Now, what's going to happen very often is that the screen is not going to talk to the LED driver properly, and it's going to cause you to have no backlight. So let me just go back to the, where was I? Here. Yep. So this is the LED driver page. Now, here's the way this is going to, this is what's going to happen. This is the failure mode that you're going to have. So up here, you're going to have 8 volts at the fuse, you're going to have 8 volts at the current sensing resistor, you're going to have 8 volts over here, but you're not going to have any voltage coming out of this transistor. Now, Q7706 is what is going to send power through to the coil and this whole circuit over here. But this is a P-channel MOSFET. So being a P-channel MOSFET, it's only going to send voltage through if the voltage in the gate, which is pin 3, is lower than the voltage on pin 4, which is the source. And if you're not sure, I know they don't label anything here. It used to say stuff like source, drain, and gate. You can always just Google the MOSFET to see if it's a P-channel and also what each pin is. So the way this works is when there is lower voltage at the gate than the source, it will open. R7701 is taking the voltage from the source and putting it on the gate to ensure that it's never going to open because it's always the same. Now, R7702 over here, this changes everything. This allows this circuit of two resistors here to be seen as a voltage divider. And once this is working as a voltage divider, if it's given a path to ground, then we will have a lower voltage on the gate than we do at the source, and this will open. Now, this is not tied to ground, it's tied to the backlight driver, which will then tie it to ground if it sees that all conditions are met. So the backlight driver is going to say, okay, we can control whether this voltage divider works, we can control whether this transistor opens, but I just want to make sure a few things are okay first. First things first. Are we using too much current here? Are we using too much current? If we're using too much current, it closes it. The second thing it's going to do is it's going to talk to the screen. It's going to say, screen, how are you feeling? You feel like being a screen today? You feel like lighting up? Did somebody accidentally plug in some kind of bullshit non-Retina screen into us? Maybe did they plug in an A1278 screen? Oh, no, okay, you're the proper screen? All right, open up. Now, we need those two things to work. And what often happens is that there's something wrong with this I2C line. Now, the first thing that can be wrong with it is that somebody used the screen of the wrong fucking year. Happens all the time, and then people wonder why it doesn't work. Buy the proper screen for the proper year. Yes, I know they all look the same. I know that they look the same, they appear the same, they have the same specs, but that doesn't mean they're not different screens. Again, we're dealing with Apple here, and Apple makes things hard for no good reason. So make sure you're using the screen of the same year. Now, the next thing that you're going to see is that sometimes this line, even when it does not measure a short to ground, is actually broken. So when you're dealing with data lines, very often you can tell if it's broken by measuring resistance to ground. Now, if you measure resistance to ground over here, you're probably going to get something around, I don't know, maybe 2 kilo ohms around there. Now, here's the funny thing. You can measure resistance to ground on this line, and you can have a high resistance even when the chip itself is shorted to ground. The funny thing about this new LP8548 chip, and what's really interesting, is that when it fails, it will short to ground, but it will only short to ground when you turn it on. Let me repeat. So you can measure for a short to ground on either one of these I2C data lines over here, and what is very interesting is that you will get a very high resistance to ground, which will lead you to believe that that's not a problem. It will lead you to believe that it's not short-circuited. But when you turn it on, even if you don't have a screen plugged in, you will notice that the backlight SDA line is something like 0.4 volts or 0.5 volts, when it's supposed to be 5 volts. And this pull-up resistor over here will be fine. So the pull-up resistor that's supposed to be pulling this data line of 5 volts will measure its 1.8 kilo ohms. It won't be corroded. And now, what you can do over here to figure out for yourself is what you can do is you could remove this resistor to rule out the screen being an issue. So if you remove R7762 and remove R7763, you can see, okay, when I measure, if the data line goes back up to 5 volts, then I know the LED driver was bad. If it doesn't, then there's something with my screen. But what I find really interesting is that this is one of the few times where the data line is pulled down to ground only when the chip is turned on, not when it is off. Because that's not something that I'm used to. When any one of these ICs fail, you'll notice that you have a very low resistance to ground on the data line, even when there's no power applied. Whereas here, when this specific LED driver fails, its data line will short itself to ground, but the short to ground will only present itself when it's turned on, when you're obviously not in a mode where you can measure resistance. The only way that you would know that is that when you plug it in, even when you're applying that 5 volts to the data line, it's internally pulling it down to 0.5 volts. Now, how the way this manifests itself on some of the older Retinas is a little bit different, and I'm just going to bring that up because that's something that drove me absolutely out of my mind in one of the previous videos that I did. You can have a similar problem on the Retina, but for the 13-inch Retina, but it'll occur for a slightly different reason. So, okay, here we go. So on this machine, let's just go back here. So this is a 13-inch Retina, not the 12-inch Retina. This is the A1502 model. What you'll notice is this I2C backlight SCL line has a capacitor on it that is hidden all the way on the top of the page somewhere. So this is going to go to the display connector. Okay, this is the interesting part here. So this is supposed to go to the display connector, right? But when I hit Control F, it's not actually bringing me to it. Oh, duh, because I have to put my... See, they don't have underscores in it, so I got to add my underscores myself. See, this can trick you if you're in a hurry. So by the LED driver, it has underscores. I mean, it doesn't have underscores, but by the display connector, it does. And by underscores, you see this little character over here. So I won't be able to Control F it as easily, and I need to be able to Control F it. Always got to be able to F your stuff. So I2C backlight SDA is going to have this little capacitor here, and it's really easy to forget about this capacitor because it's at the top of the page, it's not near the signal. So you got this little capacitor to ground over here, and if we were to go over to the board view software, one of the things that you may notice in the board view software is that that capacitor is not near the LED driver or the display connector. It's kind of out there in left field, and it's very, very common that that little capacitor can go bad. So let me just add the board view software so that you can see that on the screen. I'm just going to capture, add existing, and give me my Landrex. All right, here we go, Landrex. So if we look for that little asshole of a capacitor, you'll see I2C backlight SDA is CA358, I believe, CA358. And look at that. Look at where it's located. So the LED driver is down here. All the way in the corner of the board, you have this capacitor, and it's on the opposite side of the board from the LED connector, and it's all the way out of left field from the LED driver. So it's really easy to forget to check that capacitor because it's so far away. But you know, people smash that capacitor when they're taking the board out. You know, people like to use their fingernails. They use their fingernails, they tap. You know, they either scrape things off. Scraping that off is not going to cause it, or they smash it, which is more likely. So always make sure you're on the lookout for these I2C lines between the screen and the LED driver. They did not exist in the A1278, they didn't exist in the A1286, A1297, but they do exist in these newer models, and the failure mode is really, really weird. So that's it for today, and as always, I hope you learned something.